Okay, this is pretty fun. We're on to law of cosines now, and one of the great things about law of cosines is we don't have the situation where we have the ambiguous triangle where we have to look at what the angle might be. Oh, and what if that's a reference angle, and we look for the other side. And that's because, you just recall, like sine returns values in these two quadrants. So if we're talking about a positive quadrant, the positive value is going to return it in this quadrant, but that could have been a reference angle over here. Cosine, however, returns values in the first quadrant and second quadrant. And that's where our values are going to fall for a triangle. It's going to be between 0 and 180. So if you have an angle that's bigger than 90, but smaller than 180, the law of cosines can return that. Now, it doesn't always work in every situation. Sometimes we have to use law of sines, but it is nice that we have this. I'm trying to change the color. So it was set on blue again. It's nice that we have this tool at our disposal. So the law of cosines states that the square of any side of a triangle is equal to the sum of the squares of the other two sides minus twice the product of the other two sides and the cosine of the included angle. For triangles labeled as in the figure here, with angles A are alpha, beta, gamma, and the opposite corresponding sides, A, B, C, respectively. And respectively means A goes with alpha, B goes with beta, C goes with gamma. So they line up in that same order. The law of cosines is given as three equations. A squared equals B squared plus C squared minus 2BC cosine alpha. B squared equals A squared plus C squared minus 2AC cosine beta. And C squared equals A squared plus B squared minus 2AB cosine gamma. And then you can solve for these three in this format, solving for cosine alpha, beta, and gamma, and you get these. And I think it's nice that this book actually gives us these the formula in this format as well, because if we want to find alpha, it's going to be cosine inverse of this quantity, and beta is cosine inverse of that quantity, and gamma is cosine inverse of that quantity. So let's go ahead and move on to how to find the measures of the remaining side and angles of a triangle given side, angle, side. That means two sides and the angle between them. It's also known as SAS triangle. So sketch the triangle, identify the measures of the known sides and angles, use variables to represent the measures of the unknown sides and angles, apply law of cosines. I should make that bold. Apply law of cosines to find the length of the unknown side or angle. I apply the law of sines or cosines. Let's make that bold too. To find the measures of a second angle, and then compute the measures of the remaining angle. So here we go. We have C equals 12. Angle beta is 30, and side A is 10. So let's find side B, and so I'll use B squared equals A squared, let's do this, A squared plus C squared minus 2AC cosine of beta. So B squared is going to be 10 squared plus 12 squared minus 2 times 10 times 12 times cosine of 30 degrees. So B is going to be the square root of what? That's 100 plus 144 minus 240 cosine of 30 degrees. We know what cosine of 30 degrees is, so let me get my eraser out. Cosine of 30 is, and you all know this from memory, right? It is square root of 3 over 2. Yes. Okay, very good. So our B would be approximately, let's see what that would be. We have 6.013. So now we can use law of sines to find the next angle. Now, my recommendation is find the smaller angle. That way we can avoid, using law of sines, having the ambiguous case. So the smaller one has to be acute. The other one that's larger could be acute or could be obtuse. So find the smaller one. So we'll go with sine of alpha over 10 equals sine of 30 degrees over the 6.013. So our sine of alpha is going to be equal to 10 times sine of 30 degrees divided by 6.013. So alpha would equal sine inverse, or arc sine, of 10 times sine of 30 degrees over 6.013. So alpha would be approximately, let me get this up here, 56.3 degrees. And now probably the easiest calculation we're going to do is our gamma is going to be equal to 180 degrees minus 30 degrees minus 56.3 degrees. And for that, I get approximately 93.7 degrees. And there we go. We found all the parts of the triangle. So the stuff we calculated, this value, and this value. Okay. Let's look at another one of these. Let's find the angle alpha for the given triangle with the side A equals 20, B equals 25, and C equals 18. So we could go back up and use that other formula that started with the alpha part. So like if we were to go back up here, we could use this formula right here without drawing the whole triangle. So all we have to do is find alpha. So cosine of alpha is going to be equal to b squared plus c squared hang on a second, make sure I get this right, minus a squared over 2bc. Okay, so we have and then alpha would be cosine inverse of, or our cosine of this expression. So our b is 25, so 25 squared plus 18 squared, that's our c squared, minus the a, which is 20, we're going to square that, divide everything by 2 times 25 times 18. Now, one thing I want to point out about this, I would make sure I did parentheses for the numerator and parentheses for the denominator between the division. So if you're doing this on the calculator. And what we get out of this is approximately 52.4 degrees. Okay. And that'll be it for this video.